In this video, I talk about discrete probability distributions. The first four questions deal with a variable being discrete or continuous. A discrete variable can be counted, for example, 1, 2, 3, etc. A continuous variable can't be counted, for example, the amount of cola left in an 8-ounce glass. It can be any amount from 0 to 8. It could be 2.3452 ounces. Question 1. The number of oil spills occurring off the Alaskan coast. This is discrete because spills can be counted. Question 2. The number of freshmen in the required English 101 course. Freshmen can be counted. It is discrete. The height of a randomly selected student. This is continuous. Height can't be counted. Question 4. The braking time of a car. This is continuous because braking time can't be counted. Question 5. Determine whether the following is a probability distribution. If so, find the mean and standard deviation. If not, identify the requirements that is not satisfied. X equals 0, 1, 2, 3, and 4. And P of X is 0.31, 0.45, 0.09, 0.08, 0.07. Each probability is between 0 and 1. Also, if you add 0.31, 0.45, 0.09, 0.08, 0.07, you get 1. This is a discrete probability distribution. To find the mean, use the formula mu equals the sum of the product x times p of x. To find the standard deviation, use the formula the square root of the sum of the product of x squared times p of x minus the mean squared. The mean is 0 times 0.31 plus 1 times 0.45 plus 2 times 0.09 plus 3 times 0.08 plus 4 times 0.07. This gives you 0, 0.45, 0.18, 0.24, and 0.28. When you add the amounts, you get 1.15. The mean is 1.15. To find the standard deviation, first square each x value. You get 0, 1, 4, 9, and 16. Next, you multiply each x squared value to the corresponding p of x. You get 0, 0.45, 0.36, 0.72, and 1.12. Add the values together, you get a sum of 2.65. The standard deviation is the square root of 2.65 minus 1.15 squared. This gives you 1.152. Question 6. The values of x are 0, 1, 2, 3, 4, and 5. And the values of p of x are 0.2, 0.213, 0.191, 0.146, 0.227, and 0.239. Each probability is between 0 and 1. If you add all the probabilities together, 0.220, 0.213, 0.191, 0.146, 0.227, 0.239, you get 1.236. This is not a probability distribution since the sum is not 1. Question 7. In a raffle, the prizes include one first prize of $5,000, 5 second prizes of $1,000 each, and 25 third prizes of $300 each. In all, 10,000 tickets are sold at $2 each. What are the expected net winnings of a person who buys one ticket? In this problem, you must construct the probability distribution. Here are the possible values of x. 4,998, because remember you paid $2 for the ticket, so you actually only win 4,998. The other values are 998, 298, and you could be out $2. You have a chance at winning one of 3 prizes, or you could lose and be out $2. The corresponding probabilities are 1 out of 10,000, 5 out of 10,000, 25 out of 10,000, and 9,969 out of 10,000. There are 9,969 losing tickets since there are 31 winning tickets. To find the mean, multiply 4,998 times 1 over 10,000, 998 times 5 over 10,000, 298 times 25 over 10,000, and minus 2 times 9,969 out of 10,000. This gives you the following: 4,998 out of 10,000, 4,990 out of 10,000, 7,450 out of 10,000, and negative 19,938 out of 10,000. Now, add the amounts together, you get negative 2,500 over 10,000, which equals minus 25 cents. If you were to participate in many raffles of this type, you would expect to lose 25 cents per raffle. Question 8. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to an 18-year-old male for $350. The probability the male will survive the year is 0.998789. Compute the expected value of this policy to the insurance company, then interpret your results. We are looking at this question through the eyes of the insurance company. The two values of x are 350 if the male survives and negative 249,650 if the male dies. The corresponding probabilities are 0.998789 and 1 minus 0.998789, which equals 0.001211. Now we multiply the 350 times the probability 0.998789 and negative 249,650 times 0.001212. From this you get 349.57615 and negative 302.32615. If you add, the mean is $47.25. If the insurance company were to sell many policies of this type, they would expect to make $47.25 for each 18-year-old male that they insured. Question 9. Assume that a researcher randomly selected 14 newborn babies and counts the number of girls selected. The probabilities corresponding to the 14 possible values of x are summarized in the given table. Answer the questions using the table. Find the probability of selecting exactly 5 girls. If you look at the table, for 5 girls, the probability is 0.122. Find the probability of selecting 2 or more girls. If you use the complement of 2 or more, which is 0 or 1, you have 1 minus the sum of 0.000 plus 0.001, which equals 0.999. The answer is D. Question 11. Focus groups of 12 people are randomly selected to discuss products of the famous company. It is determined that the mean number who recognize the famous brand name is 6.9 and the standard deviation is 0.70. Would it be unusual to randomly select 12 people and find that greater than 10 recognize the famous brand name? To answer the question, you have to determine the minimum and maximum usual value. The minimum usual value is the mean minus 2 standard deviations. The maximum usual value is the mean plus 2 standard deviations. The minimum is 6.9 minus 2 times 0.7, which equals 5.5. The maximum usual value is 6.9 plus 2 times 0.7, which equals 8.3. 10 is more than 2 standard deviations above the mean, therefore it is unusual.